Sorry about that, guys. We got cut off from the last time. So what we're going to see now is, let's go back and review this. Using a greater force makes the ball move at a greater speed and at a greater distance than using a blank force does. So the force applied in the same direction of an object tends to make the object move faster. The object moves in the same amount of time. The force applied in the opposite direction makes it move slowly or stop moving. Okay? Now think about different ways of forcing the same baseball. Right here, they're talking about if you hit it harder, the more it's going to go. Right here, the greater speed at a greater distance than using a smaller force does. The motion of an object also depends on the blank of an object. The motion of an object also depends on the mass of an object. Mass is the amount of matter that makes up an object. Matter is anything that has mass and takes up space. Mass and takes up space. My 5th grade teacher used to make a joke with us every single time. He'd go, "What's the matter?" And we'd have to say, anything that has mass and takes up space. With an object with blank mass will likely move blank and farther. So the heavier the object, right? Nope. What does it say? All matter has mass. An object's mass determines on how much force will be changing its motion. Think about the same force. I'm sorry, I didn't read this to you. That's why you're looking at me. Think about the same force pushing on two objects with different masses. The greater the mass of an object the force is acting on, the less the force will affect it. So the object with less mass is likely to move farther and faster. So think about it. Tennis ball versus bowling ball. If I put the exact same amount of pressure on it, which one's going to move faster? Well, the tennis ball, because what? It weighs less. But the bowling ball weighs more. So I'm going to have to put more force in it. So think about here. An object with less mass will likely move blank and farther. It's going to move what? Yep, faster and farther. A blank is a tool used to measure force. We haven't gotten to that part yet. Next page. Suppose you use a ping pong paddle to hit both a bowling ball and a ping pong ball. The mass of the bowling ball is much greater than the mass of the ping pong ball. If you hit both balls with the same force, the ping pong ball will move faster and will also move farther. Now, suppose you have an empty wagon you want to use to move a pile of books. The mass of the wagon, when it is empty, is less than the mass of the wagon when it is loaded with books. Makes sense, right? It's empty, it's going to weigh less. And if it has more, it's going to weigh more. If you pull the empty wagon in a certain force, it will move faster. When the load of the wagon with books, the mass increases. The greater the mass of the wagon, the less your pulling force affects its motion. If you pull the full wagon with the same force you use when it's empty, its motion will be less affected. The full wagon will move slowly when it is empty. So think about it. A blank is a tool to measure force and it measures unit called blank. We haven't gotten to that either yet. So this right here is just describing what we were doing. Okay? A spring scale is a tool used to measure force. Oh, perfect. That answers that question. A blank, a spring scale is a tool used to measure force. The force is measured in units called. You can use a spring scale to measure the push or pull of an object. A spring scale has a book at the end of the spring. When an object is attached to one book, the object pulls on the string. A pointer on the string shows how much the force stretches the spring. The force is measured in units called newtons. Suppose you need to move a heavy object across the floor in your classroom. Explain how you would use the spring scale to measure the force you must exert to move the object. So what are you going to do? Think about that. Suppose you need to move a heavy object across the floor in your classroom. You're going to push it, right? How are you going to use the spring scale to measure the force? What's another way besides pushing? Pulling, right? Why couldn't I use the spring scale to pull and determine the force that I have to do in order to exert it? Okay? Now, we're going to look down here and do our questions down here. Okay? Which of these affects the motion of an object? A, the position of nearby objects. B, the force acting on the object. C, the object's length. Or D, the age of an object. Which of these affects the motion of an object? Think about what this whole chapter was called. The whole chapter is called Force, Mass, and Motion. So I'm going to tell you right now, you could probably rule out D, because what does age really have anything to do with anything? So think about it. Choose the answer. A student uses a bat to hit a softball with a certain force. When she hits the heavier ball with the same force, how does the heavier ball move compared to the lighter ball? So you're comparing the heavier ball to the lighter ball. So what you're going to describe first is the heavier ball. Is the heavier ball going to move faster or slower? A, it's going to go faster and farther. B, it's going to go faster but not as far. C, it's going to go more slowly and farther. Or D, more slowly and not as far. Think about the key word here. She hits with a heavier ball with the same force. Keyword same. Which of these is a force? A spring scale, an object's mass, a push upward, or an object's matter? Which of these is a force? Think about what force means. Go back into your notes if you don't remember what force means. Force is a push extends as a push away from you. A pull is a force towards you. So it just kind of gave you the answer right there just by going back and looking at your notes. A student pulls 4 classroom objects with the same amount of force. On which object's motion will the pull have the greatest effect? So a student pulls 4 classroom objects with the same amount of force. In which object's motion will the pull have the greater effect? Okay, take a moment. Same amount of force. It's going to have the greatest effect. Okay?